Hello and welcome back everybody, finally, to another ConveyorU video, and today we will be talking about a long overdue topic, which are first in first out buffering systems, buffering or accumulation, and we'll see right in this video why it's important to take note of this difference. It has been a while, and this topic it was introduced some months ago, so I hope you can recover the last videos that we did about buffering and about last in first out buffer, and you can compare these two solutions that we are going to explain now. First in first out buffer, naturally, it means that the first product to get accumulated or buffered is the first one that goes away, and this seems a pretty good idea because it's ideal for every kind of product. The one with long shelf life, the one with that are fresh, the one that are frozen without any problem. So why not use always this kind of logic to handle the buffer? Well, there are several reasons that should bring us to use this kind of solution only when is really needed. And first of all, for one, they are much more expensive than the last in first out ones, and also they take away much more wider footprint inside the plant, inside the building, and those two reasons should be more than enough to bring us to carefully consider to use first in first out accumulation or buffering systems only when really is needed. Okay, but this is not all. Mechanically speaking, and also in terms of electronics and software, first in first out buffer tends to be a little bit more complicated rather than the last in first out ones. So there are several topics and arguments that bring us together to a solution that could be different from first in first out. Let's see when we need a first in first out buffering system really, and which are the best solution available on the market when really is needed. Okay, so it is obvious that the first in first out is mainly needed when the products are fresh and they cannot stay outside of a package or outside of a cold area or freezing area for a long time. And so this is the typical situation in which first in first out should be not only preferred, but it's a must. It's mandatory to use first in first out. And then there are other situations, for example, when you need to keep some kind of traceability of the production. So you want to be sure that you keep the sequencing of the products coming inside the buffer, okay, and then going outside the buffer, or even more, you want to keep the sequencing of the product coming inside the line and going to the downstream part of the line. So this is typically needed when, or again, fresh products, but when you have products that can have a high risk of contamination, meat, cheese, this kind of production that need to have traceability of the whole production the whole time. Okay, so before taking on the topic about the different kind of buffering system and accumulation, first in first out, let's remember what's the normal condition of accumulation, because that is actually a first in first out. If we have a conveyor with products running on it and we simply put a stop on the conveyor that is still running, the products will push one against the other, they will close the gap. So in let's say 10 meters of conveyor space, if we had 5 meters of space occupied by products before of the stoppage of the downstream line, what we see is that we have 5 meters of space available. But of course, in this configuration, in this wave of handling accumulation, there is pressure and increasing pressure on the products. Therefore, that is not always a possible solution to handle the accumulation first in, first out. So let's see what we can do in another way, okay? Buffering systems, okay? So a buffer is a device, another conveyor typically, that takes the product out of the line and store them inside a convenient area where you can gain a lot of meters of buffering space of conveyors available with a reduced footprint inside the plant. So if we keep a look at the sequencing, and let's say that we have products numbered in increasing value from the first one to arrive to the last one, okay? Let's say that after the product number 3 has passed, the line downstream stops, and we begin to load the buffer, okay? And we load from product number 4, let's say, to product number 18, and this is the available space. So we designed this buffer in such a way that we have a zero pressure, as we did in the last in first out solution that we have, okay? So what happens when the production downstream goes back online? Let's see that. Okay. Typically, since the upstream production cannot stop and will not stop, when you go back online with a buffering system, you will be, even if you give back with a first in first out logic, what you will see is that there is mixing between the product that have gone inside the buffer and the one that have been arriving from the normal line. So, and this is going to be handled like with a merger system, okay? So let's look at the numbers. If we look at the sequencing, let's say that product number 1, 2, and 3 go away straight into the downstream machine. The first product that passes and goes downstream is product number 19. Then we have the merger from the buffer that will send again product number 4, and then we have product number 20, and then we have product number 5, and then 21, and so on and so forth. So the buffer itself is unloading with a FIFO logic, but we are not keeping the exact sequence in the product that has arrived on the line. And this may be okay if we have a product that have a decent shelf life and are able to stay a little bit outside of the cool area, or in any situation in which you don't need to guarantee the complete traceability of the product, because in this way you may have a mixing between product and for whatever reason sample control of the products downstream, always talking about food of course, find out that there is a contamination in a lot of production. You will need to retire from the market a much bigger number of products for the simple reason that you were not keeping the sequencing, so you will have, let's say, to discharge the whole production of the day, while maybe only a limited number of products. So in all this situation, the buffering first in first out may not be sufficient, okay? And in that case, we have two solutions. One is find a way to make accumulation but with zero pressure, and the other one is an hybrid system, let's say, between these two. Let's go and see which are these ones, okay? So zero pressure accumulation. Zero pressure accumulation is achieved with a special kind of conveyor that basically is capable of increasing its length in real time according to the needs of the line. So when the conveyor is running straight to the downstream machine, it will be a short section, let's say a few meters, but this kind of device needs to be capable of flawlessly increasing its available space, and this is a bit tricky. We have around in the market this kind of solution is used with horizontal accumulation conveyor and also with spirals. As for MH, we don't manufacture this kind of system ourselves, but we do integrate very clever systems from one of our partners, which is the well-renowned company Ambaflex. And let me check, just a second, I need to remember which were their numbers. Oh yeah, okay, so we are. To get into the technicalities of this buffer, I will put around here somewhere the links to their AVH and AVD systems that can be used for this kind of solution. Okay, they are very interesting. Both of them have their own field of application, and maybe in the future we can look deeply inside these systems. But if you look at the video on the Ambaflex YouTube channel, I'm pretty sure you will understand. Anyway, if you need to talk about this one by one, drop me a message, we can organize. Okay, so this is a real-time zero pressure buffering system with Ambaflex systems, of course, with Ambaflex spirals and also horizontal ones. Okay. Now, there is another system, as we said, which is kind of an hybrid solution between the two. And you would wonder why choosing one, trying to find another one if this one is so great, because it's pretty intuitive that if you can just increase the space, the available space of the conveyor, and decrease it when you have the production going back, and so the space is going to be reduced, the products are going away, that the sequencing of the products is perfectly kept all the time, and pressure is absolutely zero. Why look for something different? Well, mainly price and limitation of the number of meters that you can have of available space. So typically speaking, these kind of devices have about 60 meter maximum of buffering space, accumulation space available in both the configuration. Something more than it may be done, but it's not a standard unit, and these ones already have a very high price per meter. So it should be considered only if you really need this kind of solution, because otherwise you would find yourself in a little bit of a surprise when you would need to integrate one of these systems. Okay. So now let's take a look at the hybrid system that can allow us to mix kind of both of two words and trying to reduce the cost per meter of the accumulation while keeping a complete sequencing of the line. Okay. The hybrid system is basically composed by a divider at the beginning and multiple lane conveyors with independent motors. Okay. In the normal situation, so when the line is running normally and the downstream machine is running perfectly, the products will just flow through one of these multiple lanes with its independent motors, and this will be simple conveying. When there is a stoppage downstream on the line, what we would see is that of course the main conveyor lane is already filled with product, and if we want to keep zero pressure, we have no option of continuing to have these products running inside this lane. So we need to stop this lane. So the deviator upstream will shift the production to the other lane, and then to the other one, and then to the other one, according to how much space you need to make the accumulation. And in this ways you have multiple lanes, each one with perfect sequencing of the product. And so if you want to keep the sequencing also downstream, all you will need to do is basically, when the production goes back online downstream, simply empty the lanes in the correct number, in the correct sequencing that you had have them fill in previously. So you will empty completely lane number 1, and then lane number 2, and then lane number 3. And while you do this, the deviator upstream will also continue to move the product into the different lanes, as long as the buffer is completely empty and you are going back to the normal situation in which there is only one lane which is used as main conveyor line. This is a pretty simple system, let's say. Mechanically speaking, it's much less complicated than the dynamic accumulation that allow to have zero pressure. But of course, and this allow also possibly much more meters of accumulation space available. And price-wise, it's usually, of course, there is a sweet spot in terms of dimension compared to the price. But if we compare the exact number of meters available, this system sits more or less in the middle between a first in first out buffering system, which is, as we said, the less efficient, and a dynamic accumulation zero pressure first in first out buffering systems. Still, it's more expensive than a last in first out one, but at least we have a solution that can be used with a lot of scalability in terms of length and keeping the sequencing exactly correct. So this is, personally, it's my preferred solution because it's more flexible and it can be used with a much wider range of products. But of course, every product has its best solution. We do this in two different ways. One is, once again, in partnership with Ambaflex, and their hybrid system, as I would call it, is called the AVX systems. For naked products, specifically in the sweet and confectionery industry, for naked product in rows, okay, so typically it's the flow pack feeding line. We developed a multi-level belt system that can be used exactly in the same logic. The only difference is that the lanes are not side by side because we are using wide belt conveyors, but they are one over the other. So instead of the deviator, we have a tilting conveyor that moves the products on the different layer, while the line goes on to produce upstream and it is stopped downstream. So I think this covers pretty much the typical solution for first in first out buffering or accumulation. There are for sure other different ways to do this, and different let's say mechanical and electronic solutions, but these are the most common ones, and I think they are more than enough to understand which can be the best for your requirements all the time. Okay, so if you have any further questions about this kind of system, and you want to get more into the details of the machines, please drop me an email, drop me a direct message on the social networks. I will try to explain further, possibly with pictures and so on and so forth. I would say this is pretty much it for what concerns this episode of ConveyorU. See you next time. I'm thinking something new, possibly I wanted to close this season while talking about mergers and dividers, but we will see that, because maybe I will put these topics inside the next season, where we're going to speak about the complete arrangement of the line. So the choice between mergers and divider depends a lot on the whole configuration of the line, so maybe it's better to put them all in the same topic. Okay, thank you, and see you next time on ConveyorU.